another exciting episode here at IT Pro TV. I'm your host, Wes Bryan, and today we're coming back at you with more VMware. That's right, a 1-2 punch of the VMware Certified Professional version 6. Joining me back in the studios today is the VMware Boxing Master, Mr. Don Bazette. Don, how you doing, sir?
Don't know that anybody's ever called me a boxing master. It's a recipe for disaster here. All right, well, I'm excited to be back on the show, Wes. I'm ready to dive back into the world of vSphere 6. In this episode, we're going to be tackling virtual SANs, which, as the name implies, is kind of like a SAN, only fake. And so we're going to get a chance to see how that works and why we would even want to do that inside of vSphere 6. So let's just kick things off really basic here with why we would even want a SAN in the first place, right? A SAN, or a storage area network, is where we have shared storage that's available for our servers to use. And we've already talked about it in the show in earlier episodes. It's really an important piece if we want to have things like vMotion, right? Where you have a virtual machine that can move from one physical server to another physical server without rebooting. While it's online, while users are in it, we can jump hardware and really increase availability by doing that. It's an amazing thing to have. The other thing about SANs is that they're really expandable. Your normal server, how many hard drives can you fit in it? 8, maybe 10 if you get one of those bigger servers. There are some servers that are 8U high and you can fit a ton of hard drives in them, but most servers can only hold a handful of drives. So if you want a high drive density, you either need to go to external drive arrays or you can go to a SAN. And SANs can hold hundreds, even thousands of drives. They expand out and you can have centralized storage. It's really, really impressive. It's another reason why you'd want a storage area network. But there's one big reason why you might not want a storage area network, and that's the cost. SANs are expensive. And you can get cheap SANs out there. You can go on eBay or discountsan.gov or whatever website it is that's out there. I'm sure you can get cheap ones, but you don't want to rely on that for your critical storage. So reliable SANs from brands that you trust are expensive. They cost a lot of money. So in your production environment, you very well may have that. In your dev and test environment, you may not. Or if you're a small or medium business, you may just not have the budget available to do a true SAN. So what VMware did is they came up with a technology called virtual SANs, or vSANs. And with vSANs, you can take more than one server and put local storage in them and have the servers combine that local storage to create a virtual SAN. It's not a real dedicated hardware SAN. It's a SAN made up of the local disks attached to each of the hosts in your VMware farm, right? So if I have 10 ESXi hosts, I can cluster them together. I can put hard drives in all 10 of them, ideally matching configurations, and then we can bond all that together into one virtual SAN that now spans across all 10 hosts. And if one host fails, it's the equivalent of a couple of drives failing in the SAN. SANs can recover from drive failure, so can the vSAN. And so you continue on and you continue operating. And virtual machines can jump from hardware to hardware because now there's the effective same result of having shared storage, even though we don't actually have a SAN. It's a neat option. It's not something that I've used in production a ton. I shouldn't say a ton. I've never deployed vSANs in a production environment because in production you'll traditionally use a real SAN, right? It's production. You need reliable shared hardware and the investment in the infrastructure makes sense, right? But in lab and R&D, in test environments, for small business with internal projects, vSANs work great, and I have deployed that on a number of occasions because it's just a great solution that doesn't incur the huge cost.
And Don, I know you've worked with SANs a lot, the physical ones that we're talking about. When we look at performance-wise, that's the first thing that I would think of in the virtual SAN. While it does give us the ability to implement one of these, what are we looking at when it comes to performance compared to the traditional SAN?
So it kind of depends on how you configure it. In some aspects, a vSAN can actually be faster than a traditional SAN. In some aspects, I mean, the stars have to be in alignment. What happens is you have local storage on your servers, and it's spread across more than one server. So if I have an ESXi host that happens to be running a virtual machine on that same host, whose storage is backed by disks that are also in that same host, that entire communication happens right there inside of that host. It can be very, very, very fast. But if that's not in alignment, if the storage is on one host and the virtual machine's on another host, now we're communicating over traditional networking, right? When you set up a vSAN, it uses regular network adapters to communicate between the systems, and that's a bottleneck. If you have a 1 gigabit network or a 10 gigabit network, that's what your data is going to be moving at now, and that can be significantly lower than what you would have in a SAN. Right. So the other thing that factors into this are the disks themselves, right? When you purchase the disks, you're going to get a certain amount of latency, or latency is not the right word. Measuring disk I/O, I'm forgetting the word. But when we do our seek time and all of the response time for when we write to a drive, if you go all SSD, if you do all flash drives, it's going to be pretty fast, isn't it? But if you do all traditional hard drives, spinning disks, right, magnetic disks, it's going to be a little slower. And you can mix them, or you can go exclusive. There's actually two models for doing a vSAN. So let's talk about the two models. There's what's called hybrid and all flash. Okay, and like the names imply, hybrid is where we mix magnetic disks with solid state disks. And then all flash is where we just have entirely SSD. Now, when you go to deploy a virtual SAN, I guess I should mention this. It's a lower cost than a SAN, but it's not free. You actually have to have a license for virtual SAN. It's a licensed feature. It's not included, even if you have vSphere 6 Enterprise Plus with operations management, right? The big one. It doesn't include vSAN support. You have to buy the vSAN license. And when you buy the license, it comes in two modes. It comes in the standard mode and the advanced mode. Standard is geared for hybrid, and the advanced is geared for all flash. So if you want to go all flash, you certainly can, and you're going to have a really fast vSAN that's now just limited by your network bandwidth. And if you do the hybrid, you can have magnetic and flash mixed. So you have flash that's like tier 1 storage, and then you have your magnetic media that's tier 2. So everything that's being written is going to that tier 2 storage, but when you're doing reads, the reads will get cached up to tier 1 storage, kind of like the vFlash we talked about in another episode. It's very similar here, but part of the vSAN, and it's all handled automatically for us. All right, so we can go into a hybrid model and really get some efficiencies out of that. You get a lot of efficiencies on the read side. On the write side, not so much, because your writes are going to that tier 2 storage. So, so when we go to plan this out, that is something we need to think about, because we're going to need a license, we're going to need hard drives, but we're also going to need network bandwidth for this to work. And if you're going hybrid, your disks, you know, like a SATA disk, or even a lot of the SCSI disks these days, write at about 6 gigabit, right? So if I do a 1 gigabit connection between my servers, is that going to be enough to do like data migrations on my vSAN? If I have a virtual machine whose VMDKs, the virtual disks, are on one host, and I need to move them to drives on another host, how long is that going to take over a gigabit adapter? It might take too long. Well, on a hybrid model, I might be okay with that, but on an all-flash model, it's not going to be enough. So if I'm doing all-flash for my vSAN, I really need to step up to a 10 gigabit network in between my servers, and that way they can move that data between them. All right. You know, I'm talking about it in generalized concepts here. Let's. I whipped up a few diagrams to kind of help understand this. So let me show you guys some pictures here. And I'm not the diagram king, so these are a little simplistic, and I apologize for that. But it'll get the point across. This is a traditional SAN, right? When we normally deploy a SAN, you've got servers that are plugged into a fiber channel switch, and the fiber channel switch is plugged into a SAN, and all the drives are right here on that SAN. So we have a cost in the SAN itself, right? So you've got the storage processors, the disks, the array, the power supplies, all of that. Then you've got the fiber channel switch, which is typically dedicated, and it's got a cost associated with it. And you've got fiber HBAs in each of your servers that are connecting to it. All of that is part of that storage array, okay? And that's where our cost comes in. You know, even a basic SAN these days is going to be about $30,000, and they go up from there. It adds up really fast, all right? So as an alternative, we can do a vSAN. And with a vSAN, what we have is our servers have local storage, just hard drives right there in the server. We don't need fiber channel HBAs. We don't need a fiber channel switch. We don't need storage processors. We don't need a SAN array. We don't need extra power supplies. It's just drives right inside of the server. Every server can hold a few hard drives inside of it. Even the one-use servers can hold at least 2 hard drives in there. So you slap a couple of terabyte drives in there and off you go, right? And then they can communicate over a traditional network. Instead of having a fiber channel switch, I can just have a regular gigabit or 10 gigabit Ethernet switch, and they can communicate across that link to virtually bond all these drives together.
Now, Don, does that change the protocol, you know, as far as SCSI goes? Is this FCOE coming out and being put on that traditional Ethernet-based network?
So VMware is actually kind of light on the details on this. This is VMware proprietary. Like, this is something that VMware came up with that only they support. You can't mix with other vendors. And so I honestly don't know what it is that it uses on the back end. I know that this is an Ethernet network. It is TCP/IP based. You'll use IPv4 addresses to communicate across it. What we're actually setting up here are vkernel adapters, right? Remember from the networking episodes, we talked about VM kernel adapters, like our management adapter, or vMotion uses VM kernel adapters. We'll set up dedicated VM kernel adapters to be able to support the vSAN. All right, and when we do that, we'll assign them an IPv4 address, and these hosts all need to be able to see each other via that network. So this is a traditional IPv4 network. Now, whether it does fiber channel over Ethernet or whether it does iSCSI or whatever, I can't really say. It's not actually sending storage commands over these links, though. What we're doing is the host is talking to the storage just like normal, talking to its own drives just like it normally would. And this network is getting used when we're synchronizing data. So if I have a virtual machine here and it's got some VMDK stored on this first disk, I need to be synchronizing that to another disk in the array. Otherwise, I can't survive a failure, right? If this host were to fail, it would lose the VMDKs. They need to be copied somewhere else. And so it's doing replication across these links more so than like actual storage commands. And they use their own proprietary protocol for that. All right, now, when we configure something like this, it creates a really neat environment. You're certainly not going to get the same performance you would out of having a fiber channel SAN, but you guys see where the cost can be significantly lower. The VM kernel adapters here, you will want those to be dedicated adapters. You do not want to share with anything else. Don't make it be a management network. Don't make it be vMotion. Just use it for the vSAN, because the vSAN will really peg that line out. If you have a gigabit, you can pretty much guarantee it'll be maxed out.
Now, you mentioned the license norms. My company doesn't have $30,000 and up. We don't have that capability or funds to implement a traditional SAN. What are the requirements other than the license that you've mentioned in order to get this up and running and functional?
So there's the license, right? Then there's a little bit of hardware configuration that has to happen on your servers. So you can't just use any old server that's laying around. There's some minimums. If you go back and watch the ESXi episode where we showed installing ESXi, I said how the minimum amount of RAM for an ESXi host was 4 gigabytes, right? Well, if you're going to run a vSAN, the minimum is 6 gigs. Like, you can't do a vSAN on an ESXi host with less than 6 gigs of RAM. You have to have 6. But that's not even VMware's recommendation. VMware's recommendation is 32 gigs, that you need to have at least 32 gigs of RAM in each ESXi host to be able to support the vSAN. The vSAN eats up memory, right? It's building up these arrays and it's handling a lot of it in software. You don't even have to build RAID arrays on these things. A lot of times you will, right? So when I show this diagram here, and I've got these servers with storage, this might be 3 drives in a RAID 5 array, or 3 drives in a RAID 0 array, or something like that. And so now the vSAN just sees it as 1 drive, right? But I can actually leave these as 3 independent disks, and the vSAN will grab them and merge them all together for me, and now I'm basically doing software RAID, which again eats up some RAM while it's processing all of that. So they really want 32 gigs of RAM, but 6 gigs is the actual minimum. So if we try and turn this on with less than 6 gigs, it'll fail. If you have 6 gigs, it'll actually turn on. So we need to have that. I already mentioned network adapters, right? If you're doing hybrid, you can get away with a 1 gig adapter. If you're doing all flash, you really need to have a 10 gig adapter or more. 40 gig adapters are becoming pretty common these days. That would be even better, right? Think about your drives. Most drives these days are 6 gigabit drives. Right, so when you buy that brand new shiny hard drive and you look right on the cover and it says 6 gigabit data transfer rate, well, if you're only using a 1 gigabit network, what did you just do? You've hamstrung yourself, right? You can't support the bandwidth of that drive. Now, you are just sending synchronization data. It may not be that bad, but you're likely going to be behind. And so if a failure ever occurs, you just lost data. Your server will come up, but you lost a few minutes of data because that's how far behind you were on your synchronization. So we don't want that. We want to make sure that we have the bandwidth for it. So a little bit on the hardware side to accommodate. But once we've got that, we're pretty much ready to go. One big fat word of caution I want to throw out here, if you're going to deploy vSANs, it is really important, super important, mega important, that all of your hardware be on the hardware compatibility list, the HCL. All right, and I'll put a link in the show notes for this. If you go to VMware's website and go to the hardware compatibility list, you can actually search for vSAN, and it'll turn up all the hardware that's supported. You want to make sure that your network adapters, your hard drives, and all that are on the HCL. The reality is, the vSAN works pretty well on darn near everything. I don't think I've ever run into hardware where it wouldn't run. I mean, as long as you had enough. I have tried it on a 4 gig system, it didn't work. So as long as you have the resources, it will run, but VMware may not support you. And because this SAN exists entirely in the vSphere realm, you really need somebody to help if something goes wrong. And VMware, they're that person, right? So we want them to be able to help us make sure your hardware is on the HCL. All right, so one other thing, just kind of a guideline that VMware throws out there, if you're doing the hybrid model, if you're doing all flash, 100% of your drives are going to be flash drives. If you're doing hybrid, their recommendation is that 90% of your storage be magnetic and 10% of your storage be flash. Now, you can certainly mix it up, and you can go 50-50 if you want. It's not going to stop you, but their recommendation is 90-10. And the theory is that you really only access about 10% of your data frequently. The other 90% is infrequent. Like when you boot your operating system, right? Yeah, you got to read all those Windows files or all those Linux files, and you load that stuff into RAM. But once that's done, you're not really reading it off the disk anymore. So there's no point in having a bunch of flash cache available to store that when we're not really going to access it again. So 90% magnetic, 10% flash if you're going to do a mix. If you're not going to do a mix, it's 100% flash.
So we've got our infrastructure ready, we've met all the hardware requirements, the recommendations are there. Now we're ready to get started with a cluster or a vSAN, so I guess you're going to give us a demonstration of that?
Sure thing. Let's jump right into my little console here. I do need to mention one thing that I didn't mention. Before we get started, we need to have a dedicated adapter, right? We need to have a network adapter that we're going to be using just for the vSAN, all right? And this doesn't cost any extra money, there's no license here, but we need to go and define that setup, all right? So what I normally do, my recommendation, and you certainly don't have to do it this way, but my recommendation is create a dedicated distributed virtual switch. So create a DV switch, which means that we really need to have the vSphere Enterprise, right? So vSphere Enterprise is where you get the distributed virtual switches. In vSphere Standard, you just have regular virtual switches. And you can make this work with regular virtual switches, but because this is all going to be part of a cluster, you really want a DV switch, a switch that exists on more than one host. So this is kind of going to be a vSphere Enterprise solution, right? So what I've done is I've got a couple of hosts laying around. So let me jump here into my hosts. And I have a simple cluster created. And this is a cluster we actually created in one of the other shows called Lab Cluster, right? And I've got ESX host 01 and ESX host 02 chucked into that cluster. And as a part of that cluster, I've created a distributed virtual switch. Now, if you haven't seen that, jump over to our networking episode, and we covered distributed virtual switches. But I created a DV switch, which I've got right here, called vSAN. Right? And I just named it that so I can remember why I made it. Why the heck did I make that switch? Oh yeah, that's the one for vSAN. Now, I did a dedicated distributed virtual switch. You don't have to. You could just do port groups on an existing DV switch. So if you've already got a DV switch in place, you could just create a port group for the vSAN and use that to tie it in place, and it's just in one switch now. If you want to keep it simple, I'm just in the habit of always separating it out. I like to keep it completely separate for troubleshooting and monitoring purposes. It makes it a little bit easier, in my opinion. So unless you're just completely averse to having multiple switches, I recommend doing a dedicated one. So I've got this vSAN DV switch, and inside of it, I've made one port group called the vSAN port group. All right, just a standard port group, nothing magical about this thing at all. All right. Now, when I created that port group, I designed that to be the one that's going to be used for the vSAN. Now, I didn't actually do anything to it. I just named it vSAN port group, but it's just a traditional port group. So I could have added that to one of my other virtual switches, and it would be the same result. Okay. So then, what I need to do is every host that's going to be participating in the vSAN is going to need to have a VM kernel adapter that's a part of that port group, because they need to be able to see each other, right? And so that's how they're going to do it, is via that port group. And remember that whenever you create a VM kernel adapter, you've got to pick a port group for it to be attached to, and you have to pick the services that are available on the adapter, right? So if I were to jump back and take a look at my hosts, I'll take host 01 here. Host 01, when I go to Manage and Networking and VM kernel adapters, see how I've got two VM kernel adapters? The first one's the default one that was created when the management network was set up, right? So that one's there by default. I usually don't mess with that one because I don't want to lock myself out of the system, and you can do that. I created a new VM kernel adapter and attached it to that vSAN distributed virtual switch. So it's attached right there. If I edit that adapter and look at its settings, you'll see the various services that can be enabled for it, and I've only chosen one, virtual SAN traffic. I've created a VM kernel adapter that just does vSAN traffic. All the hosts that are going to be in the vSAN need this same setup. It doesn't have to be the same number, right? This is VMK1 for me, right? It could be VMK2 on another system or VMK12, doesn't matter, right? As long as it's configured to handle virtual SAN traffic and it's plugged into the same port group so that they can communicate. That's important, all right? And then on the IPv4 setting side, or you can do IPv6, we have to have network connectivity, and so I've given it an IP address, right? It needs to be able to communicate with the other host, otherwise the vSAN doesn't work. Now, when I join a host into this environment, there's two different roles they can play. What you have is a actual vSAN member, and that's somebody who's hosting storage as part of the vSAN, or you can have what's called a witness server. A witness server is somebody who's a part of the vSAN but doesn't actually have any storage. All right. The purpose of a witness server is not to hold storage, but to help us recognize when there's an outage, when a node actually fails, and I'll talk more about that a little bit later. So I might have witness servers attached also that just don't actually have storage. But at this point, when I configure it, it really looks the same. It doesn't look any different. So for example, I've got this ESX host 03 sitting out here, right? This is another host, and this host doesn't have any extra storage on it like the other guys do. But if I want to use it as a witness, I need to bring it into the cluster, and I need to bring it into that DV switch, right? So I can take host 03, and I'm just going to drag it and chuck it right into that cluster. All right, and so it's going to join the cluster. There it goes. And when I go into its networking and VM kernel adapters, it just has VMK0, right? It doesn't have VMK1 like the other guys did. So I can come in and I can create a new VM kernel adapter to get that support put in place. And when I do that, we can go in and get that attached to the other port group. Now, you can do it from here. There's a couple of different ways you can go about it. But if we do it from here, you'll see where it's got add host networking. And we can add a new VM kernel network adapter. And as I move forward, it's going to ask me the target device, and it's showing its own little vSwitch. But if I browse, I can find the DV switch. Well, see how my DV switch isn't showing up? Because I just moved into the cluster, it's not seeing it. I'm not a part of it yet. Since I don't have any ports on it, I'm not going to be able to do it this way. So sometimes you can go this way in the wizard. Other times you actually have to go to the DV switch and add it there. So I'm going to switch up to my networking. And I'm going to find that DV switch, my vSAN, and I need to add that host to the DV switch so that it'll become aware of it. So when you right-click on that, see how we've got add and manage hosts? I'm going to go ahead and do that, and I'm going to add EXHost03 to this DV switch. Now, it doesn't matter that it doesn't have any storage, because nothing I've done so far actually has to do with the vSAN. I'm getting infrastructure set up for the vSAN, not actually configuring the vSAN yet. So I'm going to add host 03 to the DV switch. And I'll say, okay, this is the equivalent of taking it and plugging it in to a switch, right? So the DV switch is like a storage switch for me. Now here's where it gets important. By default, it's going to want to set up the VM kernel adapter, which is exactly what I want, but I also need to set up a physical adapter. There's going to be a physical network adapter that's just used for the vSAN, and so I need to make sure I choose that too, not just the VM kernel adapter, or it'll end up not plugged in. All right, and so on the next screen, it's going to ask me, which physical NIC am I attaching? And I've got 3 network adapters in the server. The first one, VMNIC0, is the one I've got on my default switch. That's how I'm connected to the server. I don't want to mess with it. But VMNIC1, that's the one that I'm using for my vSAN, right? So it's a physical adapter running to a dedicated switch that I'm just using for the vSAN. So I'm going to assign that as an uplink. I'll attach it to uplink 1. You see I can have up to 4 uplinks if I want. I'm not going crazy here, I'll just do 1. But if it's your storage network, it's probably pretty important. You might want to have more than 1 adapter so you can have failover, or maybe you want to go crazy and do things like LACP to increase your bandwidth. If I had 2 10 gig adapters, I could bond them together and get 20 gig of bandwidth. That'd be pretty useful on a storage network. All right, on the next screen, it's just going to ask me basically what it's going to be a part of, and you'll see here I've got this VMK0, which is my VM kernel adapter for management. I need to add a new adapter, which is going to be my VMK1, and I can attach that to an existing network, and this time I'll see my vSAN. There's my vSAN port group. I didn't see that before because I wasn't actually attached to the DV switch. Now I am. All right, so once we've got that, we can punch it in, and here's the most important page I'm going to bump into, which is where I pick my services. I've got to enable it for vSAN. Now, I could use this for other things, but I don't want to. This is going to be dedicated just for vSAN traffic. All right, And then I do have to give it an IPv4 address. If you have a DHCP server, you can do that. But if I've got a network dedicated just for vSANs, I probably don't want a DHCP server on that network too, right? I'm trying to be as efficient as possible. So I'm going to do a static IP. And I'll just punch that one in. Notice how the gateway here, the router is wrong. So the network I'm putting in is 192.168.1, and the router is 192.168.0. That's okay, because it's not actually routing any traffic over this link anyway. If I had enabled some of my other protocols, this would be a problem, right? But since it's just a vSAN, I don't care about that. And the main reason is it's prioritizing the gateway I've got on the other adapter first, VMK0 over VMK1, and I'm okay with that, right? Because I'm not actually routing traffic on it. Same thing with DNS. I'm not actually doing any DNS lookups over this interface, so I don't really care if that's right or wrong. And then we can finish that up. When that's done, what we're going to end up with is that ESX host 03 now has VMK1 that's plugged into the vSAN switch, that's enabled for vSAN traffic. Now it's able to communicate to the vSAN. If I didn't have this done, the vSAN wouldn't be able to communicate. It would let me set it up. It just wouldn't work, right? It'd kind of waste my time. So this is an important preparatory step to get us ready to get to where we can deploy the vSAN. And once that's done, now I've got all three of those hosts in place and we're ready to rock. All right. So technically, I still haven't done anything in relation to the vSAN. We're just getting our infrastructure in place, getting things ready. Okay. Now, I mentioned that host 03 doesn't have storage. Okay. It's got storage for its OS. But on ESX host 01, I've got a 500 gig magnetic drive, and I've got a 128 gig flash drive that are sitting there ready to go in for storage. On ESX host 02, I've got a 500 gig magnetic drive and a 128 gig flash drive, and so they're ready to go into a hybrid mode. But on ESX host 03, I just have the OS drive and that's it. I don't have any extra drives in it. I'm going to use it as a witness host. Okay, let's talk about a witness host. Officially, if you want to deploy a vSAN, you need a minimum of 3 hosts. Now I say officially, you can actually do 2. If I want to do a vSAN deployment with 2 hosts, I can do it. The problem is the 2 hosts can make mistakes about whether or not they should go active for a set of storage or not. Okay, you really need 3 hosts. You need 3 so that they can properly determine when a failure occurs. And the way that happens is through what's called a fault domain. So let me talk about fault domains real quick so it'll make sense when we go and deploy it. I have another fancy pants diagram here. All right. So what a fault domain originally was designed for is a little bit different than what we actually use it for now. Imagine, if you will, a server room. And in my server room, I have 2 racks. And each rack contains a bunch of servers. And at the top of each rack, I've got a nice switch that sits up there that gives me my bandwidth, right? Maybe these are 10 gig switches. And those switches are all linked together to create my data center. So my data center might have 100 of these racks, and they're all linked together the same way. All right. In rack 1, I've got a couple of hosts. And in rack 2, I've got a couple of hosts. So I've got 4 hosts all together. All right. Now, if I create a vSAN here, I can do that. These 4 hosts can all join the vSAN. They can all see each other. They can bond their storage together. And now I've got a virtual SAN in place. Okay. And this host might go active for a few VMs. This next host goes active for a few others, and so on, right? They're each active for different virtual machines. Well, if one host fails, let's say this server right here fails, okay? The other 3 guys can't see that host anymore. And they talk to each other and they say, hey, can any of you guys see host number 4? And they all say, nope, we can't see host number 4. We get 3 votes here. 3 people all say, yeah, we can't see host number 4. And so they take over for what host 4 was doing. Whatever virtual machines host 4 was running, they now start spinning up. Whatever storage they had, they now migrate and activate in their own storage so somebody else has a copy of that data. So they bring it active, and now we've recovered from the failure and we're back in business, right? When you have multiple hosts like this, they can make that decision, right? But let me just give you a little scenario here. What if this link right here between the racks, what if it fails? That link fails, okay? Now, technically, these 2 hosts are still up and happy. And these 2 hosts are still up and happy. They're up and online. But the link between the racks failed, okay? So when that happens, these two guys start talking to each other and they say, hey, can you see host 3 and 4? And they each say, no, we can't see host 3 and 4. And they say, all right, well, they must be dead. Let's take over what they were doing and bring it back up. Meanwhile, over here, these two guys are talking. They're saying, hey, can you see host 1 and 2? And they can't see host 1 and 2. And they say, all right, well, we need to bring them active. And so now I've got a full set of my virtual machines running here, and I've got a full set of virtual machines running over here. That might not be a big deal. But if this is a dedicated storage network, I may have a real network for my actual data that's still up. And now I've got duplicate IPs and duplicate hosts. I've got multiple people hosting the same data. Things start going crazy, right? And my network fails. Now I've got a problem. We never want that to happen, all right? So you need to look at your network and recognize where you've got single points of failure, where you've got things like this link right here that could cause your virtual SAN to become segregated into multiple divisions, okay? And when that happens, we need to make sure that VMware knows about it. And so you can go into vSphere and you can create what are called fault domains. You can define it, and you can call them whatever you want. So they might not be racks, these might be buildings, right? Because a vSAN can stretch multiple geographic locations. This might be my production data center, this might be my disaster recovery data center. So you can define that. You can say, here's fault domain 1, which I'm going to call rack 1, and here's fault domain 2, which I'll call rack 2. Or here's fault domain 1 called headquarters, and here's fault domain 2 called disaster recovery, right? But the point is, as long as I have 2, it's an even number. And those 2 can become segregated, and there's no way for them to tell where the problem actually occurred. So what we need is a witness. And a witness is a third person that can get involved that acts as a tiebreaker to this whole thing, okay? A third rack, for example, or a third location, right? Production, disaster recovery, and maybe one of my branch offices or something like that. And that way, if this link right here were to fail, right? So let's say that link fails, just like I showed you a moment ago. These two hosts start talking to each other and they say, hey, can you see hosts 3 and 4? And they can't. They say, I can't get to 3 and 4. Well, they can still get all the way over here to this other rack and talk to this host. And they can ask host 5. They can say, hey, host 5, do you see host 3 and 4? And host 5 will say, yep, I see them right here. I can talk to them right here across my link. They're still up. And so now host 1 and 2 know there's a different problem on the network. We should not take over for host 3 and 4. They're still up, right? The witness gives us that third vote, gives us that extra influence, okay? And so what VMware recommends is that at a minimum, you should have 3 hosts and 3 fault domains, right? The 3 hosts should each be in their own fault domain. That would be your minimum deployment. But you can go higher. You can have 16 hosts. I think the maximum, shoot, what is the maximum? 64. You can have up to 64 hosts is the maximum. So you can have a ton. And then fault domains, you can create a ton of fault domains too. But at a minimum, you want 3. And that third one is going to be the tiebreaker, right? So that you never have a scenario where one person brings stuff online just because they think that there's an outage when there actually isn't, right? Sometimes a fault doesn't require failover. So setting up that witness is really important. All right, shoot, Wes, you know, what I wanted to do, Wes, he gives me evil eyes when he's not on camera. It's kind of crazy. But so what I want to do is I want to configure a vSAN, which I've completely failed to do, and I know I'm out of time now. So, Wes, why don't we do a part 2 on this so I can actually, you know, do what we're talking about?
That sounds good. So we'll go ahead and wrap this one up. I tell you what, do you have anything else, or do you want to go ahead and save it for the part 2?
Let's save it for part 2 because we still have a lot to do. We haven't actually configured anything yet. That doesn't mean we just wasted 30 minutes, right? Everything we did was prep work. It was stuff that we had to get put in place to make sure our vSAN works properly. So once we've got this under our belt, now the actual deployment should be pretty easy.
All right, Don. Well, thank you for being here in the studios. Look forward to seeing part 2. And you guys come back and join us in part 2 as well. Signing out for IT Pro TV, I've been your host, Wes Bryan.
And I'm Don Pezet.
We'll see you next time. The